So I recently did a data science experiment where I made predictions for future temperature readings at different places around the world, thousands of places. And the future predictions were made across a time span of roughly 6 months, from about the end of July 2021, which is when I made the predictions, and then through about mid-December, which is when I collected the new data that came in over those 6 months, and then I made a comparison. And in this video, I'm just going to randomly jump around the world and take a look at what these results look like. I did some initial investigation looking at some airports in the US, but this time I want to just be dynamic in Tableau and just pop around different countries, different locations, just to see what happened, because really, quite frankly, I don't know what all the results look like. So let's switch over to dual screen mode here. And what we're looking at is a Tableau dashboard where we have the world over here with all of these dots are where I've made predictions. The predictions are where we have data, basically, the monitoring network that I have to work with. And then in the big box here, what we see is the red line are my predictions. These are daily predictions going from basically July 16th out through December 14th, and the gray line is the actual data. Now these are 7-day moving average, so it's a central difference moving average where you do 3 days before, 3 days after where you are. And so that smooths out the data so that I could see basically where, for example, in this example here, the upper graph, if you see these stacked bars in blue, that means that the actual temperature was below the predicted temperature. In other words, it was cooler. So you've got zones of cooler than predicted, or zones of hotter than predicted. And theoretically, a good prediction would be splitting down the middle, would be going up and down, much like this one is. Sometimes here it looks like we got an extended period of anomalously cool weather compared to what I was predicting. So the 7-day moving average, we're just going to look at some of these. I'm going to zoom into the map. We're going to scan around the world and just basically take a look and see what we can find. So let's begin by, I guess we'll start over in the US, scan over to the US here. This is the location we started with, randomly chosen, was in Utah. Here's another one. Now sometimes there may not be complete data sets. So here's one from Groover, Texas, where we see that in a lot of cases my predictions were for cooler weather than actually happened. So we can just scan through these. Here's location in Nebraska. We'll go up to Washington. That's in actually British Columbia there. We'll go up here to Oregon. Sometimes there's missing data. We can see here. Come up to the Midwest. This place is in Minnesota. If we come down here to Arkansas, pretty good match. Come down a little further south to Louisiana. Scan over a little bit. Come over here, take a look. This is Waverly, Ohio. Pop down to Florida. You notice that when you go to the warm tropical areas, you don't have as much variation in temperature across the year, so it's a little easier to make predictions, I suppose. Come back up to here. Let's see what we got. Pennsylvania. Get up to some cold air areas. This one's up in New Hampshire, up in Maine. We can go up into Canada. Well, that's kind of weird. That's a weird one. Here's Saskatchewan, Canada. Here's one in Quebec. Scoot over a little bit, go further out on the coast. This one's in Prince Edward Island. It's kind of fun just to do this, just to see how does my computational approach compare to the real data. We can come down here to Puerto Rico. Puerto Rico is almost flat, but we can see that within 1 to 2 degrees difference between predicted and measured data. So let's cross over the Atlantic, pop over into Spain. What do we have in Spain? Pretty good comparison. There's another one in Spain. We'll go up to France, come up to the UK. A couple locations in the UK, some missing data there. Looks like a lot of missing data, but overall the predictions aren't bad. There's Norway, climbing, continuing to go north in Norway. In Germany, the measured data wasn't there. The predictions are there, but the measured data is not there. I don't know. It looks like there's a delay for getting the German data. Here's Italy. Scan up, go into Poland, come over to Finland. Ooh, big cold spell coming down here in December in Finland. Norway, that's not such a good prediction. A little more variation than expected. Come over here to Russia, South Russia. Let's see, what's this? Cyprus? That's not too bad. Turkmenbashi, wherever that is. I don't know where that is. Kazakhstan. Not too bad. Here's one in Iran. Let's see, go down into India. Back up into China. Probably have quite a few monitoring stations in China. Here's another China station. Here's another one. Come back up into northern Russia. Go way north in Russia. That's a pretty good one right there. Way north in Russia. Big temperature changes from positive 60 down to negative 20. That's an 80-degree variation in temperature with the predictions being pretty decent. Not too bad considering. Here's another Russia. That's interesting out on the ocean. It's just bloody cold out there. It doesn't really warm up much, it doesn't look like. Now, if we scan over, now we're back into Alaska. I want to do some southern hemisphere stuff too. Here's one from Alaska, Bethel Airport. Some pretty big, colder than expected temperatures coming in that November-December timeframe. I knew that we had some anomalous weather during that time in the U.S. There were multiple tornadoes. So let's go ahead and go back out. Let's pop down into Australia. We'll zoom down into Australia here. Take a look and see what we got. So now you notice the trend goes the other way because we're in the southern hemisphere. So you have from cooler weather going to warmer weather as you get December gets into the summertime in Australia. So pretty decent calculations in Australia. Pretty decent predictions there. You can see not bad at all. Southern tip of Australia, really good. We can come over to New Zealand. That's really good too. Southern New Zealand, that's very nice. Some middle of the ocean kind of places, not too bad. What's this here? Thailand. How's Thailand look? Of course, the equatorial regions, I think the model's going to be better than these regions of extreme temperature variation. Oh, let's go down to Antarctica. How's that look? Huh. Some missing data. Other than the missing data, the trend looks pretty good from 10 degrees up to 35. Have any others in Antarctica? What's this one here? South Africa. It's not so bad. So that's how it looks with taking a worldwide tour. Here's Greenland. other than the missing data, the actual simulated predicted values don't look too bad. Here's one in Denmark. Well, it's actually Greenland, but owned by Denmark. Way up in northern Russia. Was doing pretty good, but then they got that cold weather in November, December. That came out of the north, I guess. Colder than expected. So that's it. That's my worldwide tour, looking at my ability to predict temperatures on a worldwide scale, using the techniques I developed. It's kind of fun, kind of a nice tour. Thanks for listening.